This demonstration configures high availability for HDFS. One item of importance: HA configuration is backwards compatible. There's no need to reformat your current name node. You can begin installing high availability for HDFS into an existing cluster by adding a new master and then beginning your configurations for HA. We are going to do this by hand for demonstration purposes, but as you head towards a production environment, you would update all your build and setup scripts. Also, a small reminder: before you begin in earnest, one of the very first tasks you will complete is to update all your documentations and mappings before you begin. And speaking of beginning, our first task is to actually shut down the cluster. Now our next task is to deal with the secondary name node. We located it on master 02. There you go. It's configured to boot during startup. We need to change this. And while we're here, let's also configure the name node to turn on during boot in support of our standby services for HA. Exactly what we need to see. Now, let's advance to dealing with the journal. First thing we're going to do is install the journal software. Now we need to create a directory for the journal services. And let's turn on the journal. There you go. Now, I've completed this task already on master 01 and master 03, so we can move forward to the next step. Let's step back to HDOps so we can do some more configuration there. First thing we're going to do is deal with our init script. Here's our init script. We're going to need to make some configuration changes here to turn on and off the daemons as we've now mapped them out. Let's have a look. The very first thing we need to do is turn on the 3 journal nodes. It's very important that the journal nodes are turned on and fully functional before you turn on the name nodes. Now, let us ensure that we're going to start and stop the second name node. We're going to do this on master 02. And finally, we need to turn off the secondary name node. Great. Those are the changes that are required. Now we can deal with our actual configuration files. First thing I'm going to do is make some working copies. and then I'm going to copy in some pre-built configuration files. Here they are. Let's copy these into our configuration directory. Now, let us review the parameters and all the changes we're making. We'll start with the core file first. In the core file, we're only changing one parameter, and that is fs default my cluster. Notice we're no longer using a physical name. We're going to use a logical name called my cluster. We'll see why in just a moment. Now we make a lot of changes in our HDFS site. We're going to look at three separate set of configurations. We're going to look at the configuration for our journal nodes, we're going to look at the configurations for high availability, and then the configurations for failover. Let's start with the journal nodes. We have two parameters that we're changing. The first is dfs.nameNode.shared.edits.dir. This is how we identify the three journal servers. I want you to look at this line carefully. The value is qjournal, : we list out the master and the port number. Now notice this is a common mistake students make. This is a semicolon, not a comma. Notice it here again. The second parameter is dfs.journalnode.edits.dir. This is what we just configured, the disk1 dfsjn. Now let's look at the high availability parameters. Here we're going to change our parameters for HA. We begin by setting our logical name. We use the parameter dfs.nameServices, and we're going to set it to the logical name myCluster. Now, the next we need to identify the two name nodes. We do this with dfs.ha.namenodes.myCluster. We're calling out a name of NN1 and NN2. These are very standard naming conventions. Now we provide the RPC addresses. We're going to use dfs.namenode.rpc-address.mycluster.nn1. Now we finally set our physical server. It's going to be master01 at a port of 8020. We repeat this for NN2. Then we need to set the HTTP addresses. We do that with dfs.namenode.http-address.mycluster.nn1. And again, the physical node. It's master01 at a port of 570. This should make logical sense on why we flow these parameters as we do. Now let's look at the failover. Currently we've set two parameters for a failover configuration. The first is a class that has to be put in exactly as you see it. We're setting DFS client failover proxy provider myCluster. The class is org Apache Hadoop HDFS server name node HA configuration failover proxy provider. Now more importantly, we're setting the fencing method. We use the parameter dfs.ha.fencing.methods. Here we're taking the easy way out. We're going to use shell bin true, which will send back a shell response of true, meaning success. Now we're ready to push our files. Now that we've successfully have pushed all our configuration files, we're going to deal with the setup on master01 and master02 to establish the name node high availability. The very first thing, and one of the most critical steps, is we need to initialize the shared edits directory. We must initialize the share edits directory on the name node that has been running. Please remember also, we're using NN1 and NN2 as the shorthands for our name nodes that will be located on Master 01 and Master 02. Now, we will start up our name node. This name node is started, and it is now using our journal services for the storage of FS image and edits log. Excellent. I'd like to check the state of our name node. To do this, I'm now going to introduce a new command. It's called HA-admin for High Availability Administration. There it is, HA-admin. And here's the service state for NN1. It's in standby mode. Great. Now, let's deal with Master 02. Here we are, back here again. We're going to prepare the NN2 name node. We're going to do this by bootstrapping it. This command connects the two name nodes and the journal nodes together. And let's go ahead and start this name node. Success. But let's check the service status. Both name nodes are up, both name nodes are running, but both name nodes are in standby. Let's see how we deal with this and force one to become active. We will now execute a complex command to bring one of these name nodes online as the active name node. Here's the command line. Look at this command line carefully. We're using HA-admin, which is our high availability admin tool. We're passing a parameter with failover, and then we're passing in subparameters of force fence and force activate, identifying that we're working with both NN1 and NN2. Please be careful. Notice the extra dashes in front of force fence and force activate. It says we've been successful. But let's use our get service state to check. That's in standby. Our name node running on Master 02 is active, which means that we should be able to search our directories. Now, you need to be very careful at this stage because we do not have any of the data nodes running, just the name nodes. So let's correct that this moment. I'm going to go back. I'm going to do a complete restart of everything. Great. Now, let us just do a quick check. Now, let's check on the status of our two name nodes. Our expectation is both of them came back online and both are in standby mode. That's because we've not configured auto failover. NN1 is up. And NN2 is up. Great. We've configured high availability for name node. Now, let's move forward and validate that this all works.